Thank you very much for this opportunity to present this Rock and Talk webinar on recycling of asphalt pavements. As introduced, I'm Eshan. I am from University of New Hampshire in United States. However, right now I am located at University Gustav Eiffel at their Nantes campus as a visiting professor as part of my sabbatical leave from the University of New Hampshire. In this presentation, I will introduce the topic of asphalt recycling and talk a little bit with you about hot recycling processes for asphalt. And then my colleague and very good friend, Professor Gabriele TEBALDI, will talk with you about the cold recycling processes for asphalt pavements. So I will start by just introducing why we would consider to recycle asphalt pavements. And as with most recycling processes, one of the big impetus for recycling is economics. So we are trying to reduce the cost by reusing material. But at the same time, we are also very much interested in ensuring that our roadways preserve their geometries. So when roadways are designed, they're designed with certain geometric features. They are mainly to ensure safety of operation, to have enough clearances so that larger trucks can utilize your roadway features like tunnels or bridges or under bridges. Or at the intersections between the roadways and rail lines, there is a sufficient match of elevation between them. And then similarly, water flow due to precipitation is well managed in form of drainage. And if we don't preserve this geometry, we will have to constantly update our infrastructure, or we won't be able to use that roadway effectively. And to do that, what it means is we have to remove existing roadway or pavement before we put new layer of pavement. So automatically, since we are removing old material, it sets us up to consider recycling as a process. We do want to conserve aggregates and binders. Both of them are very precious resources. It takes a large amount of environmental cost to produce both of these in addition to your economic cost. So for preservation of environment and energy, it's very important that we recycle our pavements, which is a tremendous resource that is already in place, and why not reuse it instead of moving it into landfills? And it already is most recycled material. So people often think about plastic or glass or paper or aluminum as recycled materials because we see that in day-to-day life as we recycle consumer goods. But if you consider asphalt materials and asphalt pavements, actually in United States, it is the most recycled material, both by weight and volume, compared to any of your other commonly recycled products such as plastics or paper or glass or aluminum. Now, how do we classify recycling? So you can see a schematic here that talks about pavement recycling in general. You have the concrete and asphalt recycling. Asphalt recycling is further broken down into several categories. So the most common way or most common classification measure or measures that are in place for recycling of asphalt right now depends on location, process, and extent. By location, we mean whether we are using that recycled product right there at the pavement site or doing an in-place or in-situ recycling, or we are moving that recycled material back to some kind of processing facility or a plant where we use it and then bring it back out to the site. In terms of process, it's really hot versus cold. Hot is where we are applying heat to mobilize or melt some of the bitumen that is on the recycled material and remix it with other hot asphalt products like aggregates or bitumen to generate our new mixture to lay down on your pavement, or cold recycling where it is done without application of heat, and Professor TEBALDI will talk with you about the cold recycling processes. Also, extent of recycling, one could just recycle the top asphalt layer, or you could do recycling where you mix in that asphalt layer with your granular layers or even the soil layers. And there's a specific process to it, what is called full depth reclamation or FDR, where you actually recycle that asphalt layer together with granular layer I will not be talking about it. What I'm talking about here today is mostly what would fall under the category of surface recycling, not necessarily the full depth recycling. So we will focus on the most common ways of recycling in today's presentation, with me talking about the hot recycling and then Professor TEBALDI talking about the cold recycling. Now, a term that you always use when we are talking about recycling is RAP. RAP is an acronym. It stands for Reclaimed Asphalt Pavement or Recycled Asphalt Pavement. RAP is essentially old asphalt pavement that has been removed using a machine very similar to one that you see here, which is a milling machine or asphalt recycling machine. Essentially, this machine has a drum underneath it where you can control the height of that drum, and that drum has these carbide tipped steel teeth which are rotating and cut into your pavement to produce what looks like a final product that you see in these pictures on your slide, which is your RAP. So RAP almost looks like a granular material. It is a heterogeneous material, so you have aggregates, you have some aggregates that are covered in asphalt, and then you have some what looks like aggregates, but they are essentially portions of mastic or asphalt binder or bitumen together with fine aggregate forming a conglomerate. So process of recycling, especially to use RAP within your new asphalt mixture, it really got initiated, at least in the United States, in mid-1970s. Since then, it has become fairly mainstream, and it is really driven because in mid-1970s, there's the oil embargo and the oil crisis, which resulted in industry really trying to find resources, including existing bitumen that's already in the pavements and reuse of that bitumen and aggregate into new pavements. Today, it has become normal to use RAP. The most of the asphalt mixture produced in the United States has between 20 to 40% RAP on commonly. And that's the reason why RAP is the most recycled material in US. But it's not unusual to also see pavements that have more than 40% RAP by weight recycled or put back into a new pavement, including several trials. Especially there's been a couple done in the New York City where they've done 100% recycled pavements, where pavement is made with 100% RAP, or all the pavement is made with recycled asphalt pavement put back into that same roadway. Now, in terms of recycling or using RAP at the plant, typically we use RAP as a feedstock. So together with aggregate and bitumen, all of them are heated up or used or mixed in hot conditions. And that's what produces your recycled asphalt mixture, where some part of that mixture is really that RAP. There are some challenges that need to be addressed when you use RAP. The biggest one is, as I explained to you earlier, RAP is really a composite. You have aggregate, you have some aggregates that are covered with bitumen or mastic, and then you also have these particles which are not really a single aggregate particle, but rather a conglomerate of your bitumen and fine aggregate particles. So the challenge is when you are designing your asphalt mixture and you are considering the gradation of your aggregates in that mixture, how do you account for gradation of RAP? Because RAP could be treated as a black curve, and black curve is a term that's commonly used in asphalt industry as just taking RAP and putting it through gradation analysis or sieve analysis. Or you can treat it as a white curve, in which case you take this RAP and you use either chemicals to dissolve bitumen and remove bitumen, so you just know what the gradation of aggregate is within this RAP. Or you could also take RAP and put it in an ignition furnace where you burn all your bitumen and you are left behind with just aggregate residue. So the question is, in the actual mixture, this RAP is going to behave somewhere between black and white curve. It could be closer to white curve if the RAP was not made, is coming from a pavement that is relatively new and the bitumen is very soft. So when it's heated up, it mobilizes or melts. Or it could be a RAP coming from very old pavement where the bitumen is extremely hard And so during the mixing process, wrap stays intact and all of these black particles just act like a black aggregate. So we have to address this aspect during the design process. The second challenge is bitumen and wrap could be very variable and could range from being comparable to new bitumen or to the point where it's just acting as a solid material that will not dissolve or melt during your mixing process, because bitumen is a hydrocarbon, and the longer a pavement stays in service, the harder this bitumen gets due to oxidation or volatilization processes. So we need to know how we address the property of wrap binder, because that binder is going to interact with new binder or new bitumen. And we need to know how to compensate for stiffening or brittleness coming from this wrap bitumen. I just show you a very simple result here that shows the stiffness or modulus of wrap bitumen from several sources of wrap for some work that we did almost 15 years ago. And you can see that all of these wrap are coming from about 100 kilometers off each other, and yet the properties can be very different. This is on a logarithmic scale, so you can see that the stiffness of the bitumen and wrap could be very variable depending on which roadway that wrap is coming from. So just a very simple schematic to explain the concept a little bit further. You can think of wrap binder as an active binder, where it is viscous and it's sticky, it provides cohesiveness. If it is coming from relatively unaged pavement, or if the properties of that bitumen were such that it did not really age as well or age as significantly, or you could have very aged bitumen where it could be acting as an inactive material, where it does not have liquid-like or viscous characteristics and does not provide cohesiveness to your material, and we need to quantify that. So in terms of general mix process, now the general mix design process for asphalt materials is based on gradation control and volumetric control. You want a dense gradation, and you want to make sure that you have good balance in amount of bitumen in the mixture and the amount of air in the mixture for durability purposes. There may be some testing that could be conducted to ensure durability through resistance to moisture. Now, when you are using asphalt mixtures with recycling or with wrap, to address the gradation concern, you could use a process of fractionation, where you could take wrap and divide it into coarse and fine fraction, and that could help you answer some of the challenges with black curve versus white curve, because now you've separated wrap into what would be more representative of a white or coarser material, which is mostly the white curve material, and separate out the black curve material and treat it as a separate feedstock. Or you could also, for every wrap sample, conduct white and black curve measurement and ensure that your final product will still be okay, whether white curve was used as for proportioning or black curve was used for proportioning. Similarly, on the bitumen side, people have developed blending charts where you recover the wrap bitumen, test it in lab, and say, okay, it is 10 times stiffer than what my target is. And since I'm going to use 30% of that bitumen, maybe the new bitumen that I'm going to add into the mixture needs to be 2 or 3 times softer than what I was originally planning. And by doing that, I can compensate for that stiffness change. There are also recycling agents that have been developed in the last 5 to 10 years that are working tremendously well in being able to use high amount of wrap and in being able to soften or mobilize some of that bitumen in wrap. And I will put a plug-in for the Rilem TC 264, where this TC worked on developing procedures both for recycling agents, also for determining how much of the binder in wrap may be active by developing a degree of binder activation test procedure. Now, from production perspective, and I'll cover this fairly quickly here in about a minute, if you have a batch mixing plant, wrap is typically directly added into your mixer, so wrap does not see open flame or excessive heat, because that's not good for wrap. The bitumen in wrap can get excessively aged if it goes through the dryer drum. So in this case, the heat transfer happens from new aggregate that are very hot or heated up. And when they mix together with wrap, that allows you to melt the bitumen on the wrap and also to dry your wrap, because that's the main objective. You don't want any moisture within your asphalt mixture as a final product. When you're using a drum plant, as is common in United States, it really depends on configuration of drum. If you have a drum like you see here, which is a parallel flow setup where the burner is located here, it's heating up material as it goes through this dryer. Typically, new aggregate is introduced right at the start of the drum. And by the time the temperature in drum drops to safe level for wrap, then wrap is introduced using what we call a wrap collar in this setup. Now with this setup, you can maximize wrap amount to a certain amount. You cannot really go beyond a certain amount because there's still very high temperatures in the drum that may not be safe for use of for wrap, because bitumen in wrap once again could get too aged. So for that, you could have systems like counterflow drum, where the wrap is really introduced past the burner and the material is flowing from right to left. So the wrap never sees any kind of direct heat from the burning fuel here, and that allows you to add more wrap. Or you can use a double barrel type of setup where the inside drum is only for drying of material and to heat up your aggregate. And then once they go into this outside drum, or the gap between inside and outside drum, is where wrap is introduced and liquid bitumen is introduced, once again to protect them from this flame and very high temperature. Or you could even have a 2-drum setup. In this case, wrap was introduced with aggregate here in the drying drum, but you could also have where wrap is directly introduced into the second drum, which we call a mixing drum. So the key points to keep in mind: hot recycling, wrap can be very variable. We have to be careful, especially to make sure that the gradation and the asphalt content is not changing too much during the production. And so we have to do due diligence to ensure that variability is under check. Aged binder in wrap is properly addressed either through using softer new bitumen or through use of recycling agents, and also to look at what kind of compatibility exists chemically between wrap and virgin binders. And the solution is, especially looking forward, solutions that people are now working on are often focused on, instead of using volume-based methods for designing these materials, let's go to performance-based methods where we use a performance test to optimize the type of materials we are using and to maximize the amount of wrap or recycling in the pavement. And that often also means that you are also using some kind of recycling agent. So with that, I will stop here, and Professor TEBALDI will continue with his presentation on the cold recycling side of things.
Good morning, good evening. Thanks for attending. Now it's time to move forward in the discussion about the recycling of asphalt pavement. And we're going to talk about the so-called cold recycling. Cold recycling can be divided in 2 categories in function of the technological process selected for this operation. We can talk about cold central plant recycling. That could be in a traditional plant or in a mobile plant like the one is shown in the figure, or in-place recycling that is a recycling made using something similar, a milling machine. But the key concept that allow us to call the technology cold recycling is the fact that we don't have the necessity to increase the temperature of the aggregates. So we don't need additional head, because the carrier of the bitumen in the cold recycling technology are, in one case, the water for the emulsion technique, the emulsion related technique, or the active filler in the foam based technologies. The only energy that is required in this process. And so if you see the figure is related with the oil consumption and the CO2 emission, is only related with the transport or the milling and all the technology related with the process, like, for example, to keep the high temperature of the emulsion. Because the emulsion to be used must be mixed at a temperature that is around 60–65 Celsius degree, depending on the kind of the emulsion used. And another advantage of this technology is that one of the key concepts to use that is the minimal need for transporting of the material. In place is evident why, because we are creating the new pavement using directly the old one, or because we can move on a mobile plant very close to the working area, and we can create the mixture and lay down the mixture with the minimal transport of the material. What kind of material we are talking about? The material for cold recycling is the bituminous stabilized material. So we are talking about a material that is in the middle between an HMA mixture, fully bounded material, and a granular material, unbounded material. So we have something that use a limited amount of bitumen, so generally around 2%, maximum 3%, and some active filler. It could be cement or lime that is used to carry to catch the bitumen and carry the bitumen inside of the mixture. It's important to underline that the partially bounded has some of the advantage of the fully bounded material and some of the characteristic of the granular material. That it means that the bearing capacity is provided by the interlocking of the aggregate, so by the so-called aggregate skeleton, supported by some binding effect made by the small amount of bitumen that we are putting inside of the mixture. So, what is basically the composition of a BSM? The main element is the reclaimed asphalt pavement, that together or without additional aggregate can be aggregate that arrive from the base of the pavement or the sub-base of the pavement, or aggregate, let's say, additional aggregate if is required by the size distribution of the final mixture. After that, we have this asphalt stabilizing agent that could be foam or could be emulsion, and as I mentioned, active filler to carry the bitumen and to help the process of the management of the water, and some mineral filler that can be necessary to add to the mixture to have the proper size distribution of the aggregate. On the hand, we need also water, because as I mentioned before, there is no effect related with the bitumen, so the lubricant effect necessary to allow the movement of the aggregate to create the proper aggregate skeleton, this effect is made by water. How we have to proceed to design an asphalt mixture, a BSM mixture. Sorry for the mistake. Basically, we need to understand what the quality of the material, the depth of recycling, and the depth of the recycling give us what kind of material we have to treat. Because we can, if we work in a very superficial area, we have only bounded material. If we go down in the thickness of the pavement, we may have also unbounded material. The final thickness of the layer after the recycling, and the correct selection of the stabilizing agent. Because if we need a quick bearing capacity, a quick strengthening of the material, we can use the effect of the bind made by the cement and the fast setting of the cement. But we have to be very careful in this case, because there is the risk to bring too much stiffening in the material to create a brittle mixture. And second point, we have to make a proper formulation of BSM based on the volumetric and the compaction characteristic, as well as we have to consider the engineering durability process to guarantee the proper service life to the material. The mix design is based on a series of laboratory tests to understand exactly this point on that I has right mentioned, that are the performance and the durability. Second level, not the second in terms of importance, but the second level in the decisional process is to understand what kind of material we have available and all the economic considerations that allow to make sustainable, also from the economical point of view, is the design and the new pavement. Extremely important to understand the optimum moisture content, or the optimum fluid content. As I mentioned, the water is the element that provides the lubricant effect that allow us to reach the maximum density for a specific energy compaction. We have optimum fluid content when we have the emulsion, where we have together bitumen and emulsion in the same liquid phase. So in this case, we have to identify the optimum fluidic content. Otherwise, if we have to, if we are using the foam asphalt, we have only water, and in this case, we are talking about optimum moisture content. Optimum moisture content is important to create the specimens that are really representative of the material in the field, and also is important to understand what kind of characteristics has to have, and the amount of water that we have to put in the material during the working operation and the working phases. Now, let's talk about the mechanical performance. Mechanical performance are investigated using the IDT test. In this kind of material, we can make the hypothesis to not consider the temperature effect. So generally, for the IDT test, we use the material. We perform the test at 25 Celsius degree. We don't have any information about the plastic performance of the material, and we have to consider that the cracking is not the most important distress for this kind of material. The IDT is just a simple test that allows us to have an information about the performance of the material. And basically, it is used to identify the optimum bitumen content. So making different mixture with different amount of bitumen, checking the IDS test result, we can identify what is the amount of bitumen that will lead us to have the best performance. As I mentioned before, generally the optimum bitumen content is between 2 or 3%. Over than 3% is not economically sustainable, and we are moving in another kind of material. After the IDT test that allow us to identify the proper amount of bitumen to have the maximum performance, we have to check with another mechanical test, that is the triaxial shear test. We have to check the real performance of the material, and we can evaluate using the cohesion and the friction angle that are provided by the test to understand if the characteristic of the material are able to support the stress and strain field made by the traffic load. So basically, if the material is able to support the pavement in the service life. It's a simple test to run and give us a very important information, the information about the rutting, that is the main distress for this kind of material. Now, to finish, let's have a look in the technology. So this picture shows you a so-called recycling machine that is an operation in place, is an in-field operation. So it's the machine is a combined machine that has the part of a milling machine, and also has the part of a mixer and the pump to put in the mixer the foam bitumen or the emulsion. Same concept is used to build the plant, mobile and fixed plant. So basically, it's something that allows to mill the material, to sieve, to reorganize a mixture, put the bitumen, and lay down for compaction. So, in conclusion, what are the key points of cold recycling? Cold recycling is important, behave as a partially bonded material. It's not a granular material or fully bonded, it's both. The design procedure requires balance between the compactability, current direction, and current property. So, between the construction operation and the final performance in the service life. To support this operation, two different Rilem committees in the past year provided some recommendations that can help the designer to do properly the job. The Rilem TC237 SIB developed a method to characterize the rep to support the mix design. So basically, it's a method that allows to classify the rep and to check during the working phase if the rep used is comparable with the rep used in the mix design process. And the second series of recommendation by the last Rilem TC264 RAP that developed a method to design from the volumetric point of view the mixture, to have a preliminary design, and how to make properly specimen in laboratory, so to have specimens that are really representative of the material in the field. So we have basically to make a preliminary decision every time that we have to face a problem related or a project related with recycling, in plant or in field. In plant, we have, of course, a slower production because it's based on the use of the material in the stockpile. We have a more expensive process because we have to consider that the material is to be transferred from the plant to the field, but we have a much better control of the material, a better control of the final quality of the mixture, and we can check properly the final thickness of the material. We mill, we take out, and we put back exactly the material that we need for a specific thickness. From the other side, the advantage of the complementary method, because the holding place recycling is faster, cheaper, because it is a technology that allows to go in the old pavement, to mill the old pavement, and in the meantime, to lay down the material for the new one. So cheaper because we have minimal amount of material that came from outside, but the disadvantage is that we have a lower control of the material and lower control of the final mixture. Doesn't mean that we have a bad mixture, but of course we are not at the same level at the plant. The thickness is a limit. We cannot go in depth like we can go in the cold central plant recycling. And in some cases, due to the fact that we have always to put an HMA layer on the top of the recycled material, there is a risk to have an increasing of risk. There is a chance to have an increasing of the double thickness of the material of the pavement. So basically, cold place recycling is strongly recommended for high volume road, for very important road. The cold place recycling could be used also in important road, but is mainly recommended for less important road. Oh, in the very low volume road, we have also the chance to use to make the pavement only with the recycled material, putting on the top just an emulsion and a surface treatment to seal and to make waterproofing top of the material. So, thank you very much for your attention. Thanks to be patient with my poor English. And if you have questions, don't hesitate to contact myself or to contact Dr. Dave that was working together with me to put together this presentation. Thanks again, and I'll see you next time.